Hey everyone, today we're moving on to lesson 12, and we're going to do lesson 12 in two parts today and tomorrow. Um, so, for the first part here, we're going to talk about mean absolute deviation. And hopefully, you recognize mean, which is, of course, relating to mean that we have been finding or average of a set of numbers. And mean absolute deviation is a little bit different. We'll talk about that here as we go forward. So we're going to actually jump between the two pages of this lesson. So if you would just fill in with me the different parts that we're doing. We've got a description of what mean absolute deviation, or sometimes we abbreviate that MAD, M-A-D. Uh, so we've got the mean absolute deviation as a measure of how the data is dispersed or spread out. So that would consider some of those outlier numbers. So when we have numbers that are grouped very closely together, sometimes if a number is much larger or smaller than that common group, we call it an outlier. That's kind of what we're testing here with mean absolute deviation, is that how spread out is that data. Um, it's very useful when there's outliers in the data to use this. It's the average distance between each data value and the mean. So we're basically saying how far spread is that information from this average mean of all the data. Okay, and that's going to make sense hopefully a little bit more as we go forward. There's a little blurb here about how it can be written. Please don't stress that. It's just kind of a for your information type thing. So what we're going to do is we're going to work through these steps. We're going to practice finding the mean absolute deviation. There's 3 steps in finding it. All right, the first thing we do is we find the mean of the data. And don't forget, if you use your Desmos scientific calculator, like I said in that EOG review video, you can actually go to the function feature on that calculator, push the mean button, and then type in all these values to find that mean. It does the work for you. But if you're doing it the old-fashioned way, remember we need to get the sum of our data. So we need to add all those numbers together. That would give us 24 as a total sum. Since there's 4 values, we're going to divide it by 4. And that gives us a mean of 6. All right, that should definitely be a review for you, but that's the first step in finding mean absolute deviation. We found the mean, we found the average of all this information. Now we're going to find the distance from each data point to the mean, and it's going to be the absolute value. Now, what that means by absolute value is we're not going to talk about it being positive or negative. We're just going to talk about how far away it is from the mean. So when we look at our 4 data points, 3, 4, 7, and 10, which are written here below the lines, what we're doing is we're looking for the distance from the mean. So our mean is 6. What we're doing here is um, we're really going to go from our point to 6. So really we're going to minus 6. Now, that's going to give us a negative number because 3 is actually 3 below our mean here of 6. It's 3 below that. But we're talking about absolute value, so we're not going to write this as a negative. And really, you can just think of it as 6 minus 3, which will give us our difference of 3, our distance of 3 from the mean. Okay, it doesn't matter that it's negative or that it's below. 4 is below. It would also technically be negative, but our distance 4 is 2 below 6, and we're just going to write 2. 7 is 1 over 6, and 10 is 4 over 6. So this would be um, our deviation. How far does this data deviate from what the mean is? Okay, that would be step 2. Now finally, step 3, we're going to find the mean, or the average again, of the differences. We just calculated the differences of our 4 data points. Now we're going to find the mean again. So we will get the sum of all these numbers. That's going to be 10. divide it by 4, because there's 4 data points here, and that gives us a mean absolute deviation of 2.5. Okay, again, that was adding up to get the sum of 10, dividing it by 4. Again, we found the mean, and that's our MAD, our mean absolute deviation. Okay, now, because this number represents how far our data is spread out away from the mean, away from the average of these numbers. The smaller this number is, that means the closer our data is to the group. That's a good thing. What we want when we're collecting data is not to have data that's all over the place, that is spread way out. We have really high numbers or really low numbers that are way far away from the grouping of data. So we don't want that. We want stuff that's closely grouped together so we can understand it, we can learn something from it. So having a low mean absolute deviation is good. This is saying that on average, our numbers are spread about 2.5 above or below the mean. Okay? That's pretty good. The closer to 0 is better. The further from 0, the worse it would be, or the more spread out. So let's look at another one here. So now we have test scores for 6 students. They're listed here. We're going to find the mean absolute deviation. All right, so we're going to find the mean. We're going to see how far each number deviates from the mean, and then we'll find the mean of those differences. All right, so the mean, we need to combine our 6 data points, divide it by 6 once we have that sum, and we will get a mean of 76. Now we're going to find the deviation from the mean. How far is each of these numbers away from 76? Okay? That is going to be, let's see here. Sorry, I lost my place. Okay, so what we're going to do is we're going to see that 85 is 9 away. So let me write these numbers maybe below here. 9 away from 76, or 85 minus 76 is 9. 92 minus 76 is 16. We're going to keep going here. And then we have a big one. So 20, way far off from our data here, is 56 away from our mean, from our average. Okay, so now we need to lastly find the mean again. We need to find the mean of all these differences, these deviations. So we'll add them together, still divide by 6, and that's going to give us a mean absolute deviation of 18.66. That's much higher than what we saw in this example, where we were closer to 0. So our data was not as spread out. It was only a few away from our average here. Here we've got a big variety, especially with this last number that's pulling us far away from that average. Okay, now lastly, we've got 2 sets of data. I'm going to find one, and I want you to find the other, and we're going to compare them. So which student has more variation in his or her math test scores? All right, that's basically calculating the mean for John and for Mary. So for John, we'll calculate that. We've got John's mean score is listed for us as 83. Okay, Mary's is actually the same as well. And now we just need to find how far each of these individual test scores is away from 83. So 75 is 8 away from 83. 80 is only 3. 85 is 2. And 95, we got a big jump here, is 12. To find the mean absolute deviation now, we'll add these numbers up, divide by 5 since there are 5 data points, and get, use a different color, 5.6 is our MAD. Now go ahead and find Mary's and see whether or not her data is more spread out than John's. Okay, what you should have gotten for each of these, again, Mary had the same mean, the same average. That would mean in the grade book, they look like they have the same grade. Mary was 18, 8, 7, 7, and 12. Now, already looking at these numbers being larger, meaning these numbers are further away from the average, I can probably guess that she is going to have a bigger mean absolute deviation because her scores are more spaced out. But if you added those up, divided by 5, you get 10.4. All right? That means that her test scores are further away from this average. That's because she had a really low score here that was 18 points below her average, and she had a really high score that was 12 points above her average. Okay, notice how John didn't have any really low test scores that would have made that distance from 83 greater. Okay, so definitely Mary has more variation in her test scores, going from high scores down to low scores, where John's kind of hover. He's more consistent in his test scoring. Mary had some really good days and some really bad days. All right, now there's just a bit of information to fill in, and then I do want you to try an example of um, using the mean absolute deviation again. But fill this in with me, please. We're going to talk about something today called we'll talk about this the next time on the next lesson, called IQR, and that stands for interquartile range. And this is the next thing that we're going to find in the next part of the lesson, part 2. But we are familiar now with how to find the MAD. That's again mean absolute deviation. All right, now the mean absolute deviation works best with symmetric data. Symmetric being symmetrical. It's all kind of grouped together nicely. There's not big outliers. Okay, so we want, let's see here. We want to say that with MAD, you want the closer to 0 means data close to the mean. All right, with IQR, which again we'll talk more about next time, it's related to the median. So this is small IQR, or closer to 0. Let's see here. We'll say closer to 0 means the data is close to the median. All right, so 1 is mean, 1 is median. Skewed data is when something has a lot of outliers, and IQR is best in calculating with that kind of data. For symmetric, closely grouped data, finding the MAD is going to be best. So we have one more blank to fill in. So variables in the term that variability in the term that describes how far the data is away from the mean or the median. Variability, okay? So we want low variability in much of our data collection. And what I'd like you to do is just do one example here for me. We'll fill in the steps together on how to find the mean absolute deviation, and then I'd like you to try it here with this example. So, first thing you're going to do is find the mean. Then we find the difference, or the deviation, of each piece of data from the mean. Okay, then we take the absolute value, all right, which is something that we kind of automatically did when we did the last examples. And then finally, we're going to find the mean of the absolute deviation, which is finding the mean again. One thing I want you to skip is right here. Skip this part. That's not what we did on the last one. We just found the absolute deviation. So when we have found the mean, which is the number of family members here in these 7 families, so we find the mean. What you want to do is see how far off each of these families is from the mean and just write it here. Okay, we're already going to write it as absolute value with no negatives. Go ahead and give that a try. Now, the mean of these numbers of family members is 3.4. That's what we're comparing to here. And that is why it tells us to round to the 10th place when we're doing. All right. Yep. So we're going to. Okay, so rounding to the 10th place, which I think we don't need to round anything. I think they will be to the 10th place. We know that for this one, the family is 4/10 under the mean, and we'll just write that instead of negative 4/10, just 4/10, and then we'll fill in the rest here. All of these compared to 3.4, all these family members. And finally, we'll find the mean of all these differences, all these deviations. So we'll add them all up, divide by 7. That's 9.4 divided by 7, or 1.3. That means we have pretty good data. We have are only on average about 1 away from the original mean. So our data is closely grouped. That I would call symmetric data. So that is today's lesson. Now, on the next one, we're going to talk about IQR, which is a different idea. And you can, if you come across any of those IQR questions in your practice problems, just go ahead and hold off. We'll talk about those the next day, and you can then go ahead and answer those questions. Okay, everybody have a great day.